Hello, can you hear me? Can you hear me? In last class, we finished, I think we finished chapter 4. Yes, chapter 4 we finished, right? But we told you something we'll discuss. Uh, chapter 4. Hello, I want your response, Arya. I want a response from you. Are you hearing me? You said hello. Yes. I have 29 students so far. Yes, you can hear. So now chapter 4 we are yesterday we finished a problem, we finished an example and exercise. Now we are going to start the now we are going to start what we will start. We will start new topic. Its name is couple. Its name is couple. What is couple? What is couple? Couple is a special type of moment. A special type of moment. We are learning, we are discussing about the moment. Couple is a special type of moment. One special moment, there will be two parallel force. In couple, there will be two parallel force. Okay, they will be the same magnitude but opposite direction. Same magnitude, opposite direction, and separated by the perpendicular distance d. So two parallel force. Suppose this is a two parallel force. This will be one side and parallel force, right? And but same magnitude, like 10 kilonewton and 10 kilonewton. Same magnitude will be same, but opposite direction. It has to be opposite direction. Okay. Separated by perpendicular distance. Perpendicular distance. Suppose distance is d. D. Then this force system will be said as a d. Suppose d is equal to 5. Suppose d is equal to 5 meter. Okay. This system will be said as a couple. C-O-P-L-E. Couple, right? And moment will be moment into F into D. F into D. So 10 into 5 equal to 50 kilonewton meter. Okay. And resultant force will be 0. If it is 10 that side and 10 this side, so resultant force is 0. Right? Tendency to rotate a specific direction. So this will try to rotate in a anti-clockwise or clockwise direction. Okay. Couple moment, sum of the moment of the both couple forces about any arbitrary point. Okay. So this is the one example of the couple as I have shown you here. As I show you here. Okay. Then so what is couple then? Couple is a special type of moment where what we have two parallel forces, same magnitude but opposite direction, and separated by the perpendicular distance, and they will rotate in a specified direction. So this is called couple, right? Now, what is the properties of couple? Say scalar formation. Couple is the force into distance. The direction and same are determined by the right hand rule. Whatever right hand rule we learn, like couple is here in this example. So in this example, so this direction will be this. Okay, here it is anti-clockwise, right? Anti-clockwise. So M acts perpendicular to the plane containing the force. So a moment will perpendicular to the force, whatever. So, and vector formulation is, what is vector formulation? Vector formulation is the moment equal to M into R cross. So if moments are taken about the point A, so moment minus F is 0 about, R is the cost with the force with directed, right? Example, you see one example of moment. So couple and equivalent couple, right? So we learned what is couple, and the equivalent couple is two couple are equivalent. As example, here you see the steering wheel. You drive a steering wheel. So here is a 30 kilonewton force. Here is 30 kilonewton force, and here is the distance 0.4. So what is the moment of couple? Is the F into D. So 30. We need to just take any one of the force because forces are same. So one force is enough. So, and this is anti-clockwise direction. This is rotating anti-clockwise, so plus. So here will be plus. So 30 in 0.4 equal to, this is picture 1. Suppose picture 1, 120 Newton meter, right? 120 Newton meter is the moment. Here you see the force is increased, but distance is decreased. So what happened if you want to find the moment here? You see, so 40 into 0.3 equal to 120 Newton meter. So here you see at the end moment magnitude is same, 120 and 120, the magnitude is same. Then these two systems, so this is suppose picture 2, these two systems will be said that the equivalent couple. These two systems will be said equivalent couple. All right, these two systems will be said equivalent couple. So this is just the example of the example of the couple, right? This is the example couple. So moment couple, resultant of the couple, say couple moment are free vector and may be applied to the any point of the P added by the particle added vectorially. So for resultant moment, so resultant is just moment, just if its resultant moment is a moment R equal to M1 and N2. M1 or for more than two moments, if in more than two moments, its resultant moment is summation of R cross F. Like here is the couple, one couple is here and another couple is here. So here resultant moment is just simply addition plus F M1 plus M2. Here three couple. So that's why here will moment resultant will be summation of R cross F. So this is the formula. Now see one example of a couple is, we'll see now the one example of the couple, right? Now here you see they determine the couple moment acting on the pipe. So acting on the pipe 30 degree below the 30 degree. What is problem? 30 degree below XY plane. 30 degree below XY plane. So there, what is the couple, right? So couple is very simple then here. very simple here. We just learn it. What we learn so far, what we learn there, moment equal to, we learned moment equal to r into f, summation of r into f, right? Just that's what we have learned. So here we have ra from here to ra into f plus rb into f. Here it is rb into f. So what is the RA value here? RA value, if you take in momentum at O, so RA value is someone 0.8 J. Yes, correct. So 0.8 J, 0.8 J, R equal to 0.8 J, 0.8 J into our force is 250 minus. This is minus plus plus. Now RB, what is the RB? RB we calculate separately. RB equal to, here you see 0.6, and here is the perpendicular. So RB equal to, we can write 0.6, 0.63, sorry 0.63 cos 30 degree. Here this is the distance, RB equal to cos the I, then minus how much? 0.6 sine 30 degree J, 0.6 minus 3 plus point minus 0.3 plus 0.8 J. So R, we write down the point R, so point cos 30 degree I minus 0.6 sine 30 J, and here plus 0.8 K, plus 0.8 K. So sorry, here it will be K and it will be J, 0.8 J, and this is K into 250, and then you calculate and you will get what is the result is Newton meter. Okay, this is the couple of moment. Can you calculate the calculation and tell me result? You want to calculate it, please? No, it will be only. Please do the calculation again, and I should write down it clearly for you. So this is 0.8j into minus 2.5 k plus 0.6 cos 30 degree I, then minus 0.8j plus 0.6 sine 30 degree k into 2.5. Okay, here is the k. I don't went wrong. Here also k. So equal to, double check. So equal to, it will be double check 130 J Newton meter. Okay, tell me please, double check and tell me yes, right? Tell me it is correct or not. All right. So now, yes, it's cross project. Now, you got the result correct? Tell me please. Can you explain RB? Yeah, RB I can explain. Yeah, Muhammad Hussain, RB, right? RB we want from here to here, okay? Here to here to here, okay? Here to here. So RB is X is from here to here. X direction is here, right? X. So 0.6. So because this is 0.6, RB is the distance. This distance. Who is asking the question? RB 0.6. So this is 0.6 cos 30 degree from here to here. So RB equal to 0.6 cos 30 degree minus 0 I. Why 0? Because we are RB, actually RB meaning is ROB. RB meaning is ROB. If you want, that means O coordinate is 0, 0 and 0. And what is the B coordinate? B coordinate is x 0.66 cos 30 degree. Okay, from here to here. Okay, and what is Y? Y is from here to here. Okay, here. So point Y is 0.88, and Z is from here to here, and here to here is 0.6 sine 30 degree. So 0.6 sine 30 degree. Okay, so now if you want to find the ROB, actually it is ROB, O to B, then we know before, we learned before, x2 minus x1 I, right? So x2 minus x1 I plus y1 minus y2 I. So y1 is 0.8 minus 0 j plus Z1 minus Z2 minus Z1. So 0.6 sine 30 degree minus 0k, right? So what we got result? 0.6 cos 30 I plus 0.8 J minus, actually here it is minus, 0.636 sine 30 K, and that is we have directly actually wrote here directly, right? Here now, Hussain Jawad, here, tell me please. Yes. So this is the result. Can you check? Can you confirm me? Minus 130 Newton meter is correct? Tell me please. Okay, fine. If it is correct, so here we want to end our chapter 4. Here we want to stop our chapter 4. Okay. All right. Here we want to stop our chapter 4. Any question you have so far? Tell me please. Okay. If you are okay with that, what are you saying there? Tell me please. Doctor, can you use Doctor, we can use F cross D, right? What do you mean, Kamal Ashraf? I don't understand your question. Like in the slide, without some of the two vectors. Yes, yes. In the slide also there is other way you can do it. It's written there. You can follow that way. That's fine. There in the slide there is other way you can follow. Okay. You can do it. No problem. You can do it. No problem. Okay. So if you have now, I want to ask you. I want to ask you name call attendance. I want to give you attendance. So please respond your name when I ask your name, please. First is who is it? Muhammad Hafiz. Muhammad Hafiz. Muhammad Hafiz, are you here? Muhammad Hafiz, absent. Abdulaziz Mazen. Kumail Hussain. Kumail Hussain. Kumail Hussain, absent. Muhammad Abdulaziz bin Hussain. Zafar. Muhammad Ahmad Abdul Rahman, Muhammad Yusuf.
Doctor,
Yes.
I'm Muhammad Habs, but before that I could not talk with you on mic. For that I refresh the page.
Okay.
Okay, thank you.
Muhammad Yusuf. Muhammad Yusuf. Yusuf are here. Okay. Muhammad Sami. Muhammad Sami. Sami Muhammad Sulaiman. Muhammad Sami Muhammad Sulaiman. Yes. Both is there. Muhammad Abdullah bin Ibrahim. Ahmad Tahir. Ahmad Tahir. Abdullah Muhammad bin Abdullah. Abdul Malik Khalid. Saleh bin Munir. Umar Abdul Aziz. Ali Abdul Munaim. Muhammad Ali bin Ahmad. Muhammad Ali bin Ahmad. Muhammad Ali bin Ahmad Aspen. Isa Abdullah. Yahya Abdullah. Okay. Muhammad Sami bin Ahmad. Muhanna Walid. Muhanna Talal Jamal. Saud Usama. Hussain Ali. Faris Fahad. Faris Fahad. Faris Fahad absent. Abdul Hadi Jaber. Abdul Hadi Jaber. Abdul Hadi Jaber absent. Abdul Ilah. Ali Jawad. Hussain Abdullah. Ahmad Imad bin Ali. Ahmad Imad. Ahmad Imad absent. Abdullah Saadun. Abdullah Saadun. Abdullah Saadun.
Yes, yes.
Okay. Ahmad Dia bin Jawad. Muhammad Salah bin Salah. Hussain Jawad. Ahmad Abdul Rahman. Ahmad Abdul Rahman. Faraz Fadil bin Muhammad. Abdullah Saleh. Saad Muhammad bin Saad. Abdullah Humur. Abdul Munaim. Abdullah Said. Abdullah Saad. Umar Uhair. Muhammad Shabir. Muhammad Shabir. Muhammad Shabir absent. Shamsan Saleh. Umar Ahmad. Jamal Raid. Kamal Ashraf. Umar Sama. Abdullah Abdul Nasir. Abdullah Abdul Nasir. Abdullah absent. Musa Muhammad Isa, Abdul Rahman Sabhi, Abdul Rahman Sabhi, here. Okay, Abdullah Saeed, Abdullah Saeed. Okay, so I am double checking, right? First one, Ahmad Tahir, we're here. Ahmad Tahir, tell me please, Ahmad Tahir, not here. Ahmad Tahir, sorry. Ahmad Tahir is absent, right? Muhammad Ali bin Ahmad, Muhammad Ali, absent. Faris Fahad, absent. Abdul Hadi Jabir, absent. Ahmad Imad, absent, again absent. Muhammad Shabbir, absent. Abdul Nasser, absent, right? So I confirm it now. I cannot change later on. Dr. Ayman Bhatt and Ahmad Tahir, you are lucky. You come just the last moment, okay? So I put absent. Confirm. Now, okay, so I cannot solve the voice over there. Now we are going to start. I'm going to start chapter. What problem? Another chapter actually. Chapter 5. Chapter 5 will start today. So your mid exam will be till chapter 4, including chapter 4. So chapter 5 is not included. Now I am studying chapter 5. Okay. In chapter 5 is equilibrium of a rigid body. Chapter 5 is equilibrium of a rigid body. So equilibrium of a rigid body, what is there? Develop the equation, whatever written there, we will cover of the things. Let's see. For rigid body, this is something we already know before. Nothing new. For equilibrium, we know summation of all force will be 0. Summation of all force will be 0. Summation of all force will be 0. Summation of fx equal to 0. Summation of fy equal to 0. Summation of z equal to 0. And new thing, summation of moment also will be equal to 0. These are the equation for equilibrium. You already know this thing, right? Now, previously we learned also free body diagram. Now for the rigid body, when we say rigid body, as example, for rigid body we need to know something like suppose this is the building floor, right? Here is your table. You are studying there. You are studying your books here, your computer here. So this is the kind of rigid body, right? Where the book is resting on, tell me. Where the table is resting on? On the ground or floor. Suppose you are in the 4th floor, right? So the floor is a support here. Floor is a supporting. Right? Floor is supporting. So floor is a support. Now we need to know what is the support. What is support? Support is something, doctor, you said Thursday that the meet will be on the what stop on Thursday, right? Yes, all right. Yes, you are Hussain. Ali is being said, Ali is correct. I said it is Thursday is correct. Today chapter 4 is not included in the meet. Okay. Today's class is not included. Support something give you support for supporting your member. It is called member. Okay. Now support, what is the type of support? And support give you reaction. Like now you have the table there on the floor. You table the floor. So you table have the weight. Suppose how what weight? 10 kg, 10 kg weight. So the floor is giving the reaction opposition. The floor will give you opposite reaction, right? Equal to the 10 kilo as per the Newton law. As per the Newton's law, it will give you the opposite reaction. So support. What is the job of support? Support give you reaction. Support give you reaction. Suppose now your table is too heavy, 100 kg, and its floor is not strong. Then what will happen? Tell me please, what will happen? It's breakdown, it's fall down. That means support giving us reaction. If cannot give enough reaction, so this will be fall down, breakdown. So question is that's why for equilibrium, so reaction, so everything has to be there, summation of force equal to 0. That means supports reaction. Now we need to know the how many types of reaction, how many types of support reaction. That is we need to know types of support reaction. Types of support reaction, that's we need to know, that we learn now. Now there are three type of support. Now there are three type of support. I'm teaching you here now, and very careful. It's very important all over your life. There are three main kind of support reaction. There are three main, right? There are three kind of main. There are main support, right? Support one is I write down hinge or pin support, in hinge or pin support, right? This is two. One is roller support. Now unfortunately it is not the face-to-face class, so I cannot explain as I can explain in the room. So suppose something roller means kind of support like this, roller or ball, marble or ball. Okay, you have two ball or something, then you put some you have two ball and you put something on it. Your body is on it, right? And roller, then it will give you reaction, one way reaction. It is 100 kilonewton. Okay, 100 kilonewton. So it will give some reaction, R A R B. Give some name A and B. Okay, R A and B. So roller will give you reaction. Now reaction can happen three way. Reaction how can happen? As we know, reaction can happen vertically. Okay, vertically we learned before vertical reaction could be horizontal, and reaction could be moment. Three things. Reaction could be moment. Here, like if you if you apply the force vertically, we are applying force here vertically. How? 100 kilonewton is weight. Suppose its weight is 100 kilonewton, so it is working downward. Okay, and the roller, this is roller is giving us upward reaction. So it can give us only vertical reaction. Okay, now if I push horizontally or pull horizontally, so it will start to move. The body will start to move, right? They start to move. It will not in the rest or not in the equilibrium. That means roller cannot give us the horizontal, cannot. Roller cannot give us horizontal reaction. Are you clear so far? This is very important. Are you clear? Hello. I want response from you. Like what? Tell me. Tell me like what? What is the question? For example, for roller. Example for roller is what you see here. Example here in the picture. Here in the picture. Some supported roller. You can get this example in the bridge, but you cannot see here in the bridge. I will show you the example like what I will show you now. Okay, so you see me in the, you try to see me in the video. I will show you what is the roller. I will show you the example. Real life example. Yes, I will show you real life example. Share the video. Right? Can you see me in the video? Tell me. Are you watching me? Yes. Now I show you the, suppose roller, something roller, right? You can see my pen, right? You can see my pen. You can see there. Yes. You can see another pen. Okay. What are you watching? Now this is kind of roller. You see, it can roll. It can roll from that side. So one support, one roller. This is one roller, and this is another roller. All right, and this is my member, this bottle. So I put there. Okay, I put there. All right. So you see, this is the example, real life example. You see there something else I put there, light. Okay. So this is the example. You understand? I have two things, and the pencil is the get the reaction. Up, it is giving the upward reaction. Okay. Now, like car, not like a car. Car has a wheel. Wheel is something different. So this is the roller. Okay. So this is the roller is giving the roller is giving us the upward direction force. Now, if I want to move the bottle, that side is moving, that side. It is moving. So it cannot give the horizontal reaction. If can give horizontal reaction, I cannot move it. I cannot move. Clear? I cannot move. You understand? Now clear or not clear? Seems not clear. So like the frictionless surface. Yes, something like this. Okay. Some roller is rolling on it. Some roller reaction. So roller can give you vertical reaction, not horizontal reaction. Also not moment. Like I put some force here. I put some force here. If I put some force here, and then the bottle is want to. If I put downward force here, the bottle won't start to move like this. So it cannot give moment reaction also. It cannot give us moment reaction also. No moment reaction. Not moment reaction. Okay. It cannot give us moment reaction. So there is three kind of reaction. So there is three kind of reaction. So I write down here. This is very important, very important, very important. Okay. This is very important. What is very important? There is three kind of reaction. Reaction is three kind. Reaction type, reaction. Okay. Reaction type is three, or I can write three type of reaction type. Okay. And three type of support. Three type of support. Now, three type of reaction is what? One is the vertical reaction, vertical, RV. Another is horizontal reaction, RH. And another is moment reaction, MR. Okay. These three type of reaction. And support is again three type. Support also three type. Reaction three type, support is three type. One type is roller. What is roller? I give you example. I already give you examples. Something like this. Okay. So some weight you put the some weight. So the roller can move horizontally. So if you push this way, then what will happen? It will start to move. That means the roller cannot stop, cannot keep the body in equilibrium. So there is roller RV, or horizontal reaction cannot give horizontal reaction. If I now put some weight here, suppose some weight, I put some box or something 10 kilo. So what happened? The body try to move and fall down in this direction. Okay. That means it is going to get movement, rotate. It is going to rotate. It cannot stop rotation. That means moment, resisting moment also cannot give reaction for moment also. Cannot give কি চাবি চাবি আছে এখানে পাশে যাবেন তো চাবি খুলে নিয়ে যান তো না just wait please students. All right, are you with me here? Yes, only stop vertical reaction. So cannot give us the moment reaction. So only it can stop vertical reaction. So roller can give you vertical reaction. Okay, one reaction. Yes, time is up. Thank you very much. So next class, hopefully I will study it again. All right. Any question you have? Hello, doctor. Can I come office? Yes, right now I am in the office. Just I was asking you. Okay, you can come to office right now. I'm in the office.